Hey Math 3 students, so your homework is to complete all of the problems on pages 42 through 44, and I want to walk you through a couple of things to help you out with getting going. Most of the problems on page 42 are pretty similar to what you worked with yesterday, but by the time you hit numbers 10 and 11, there are a couple of changes that I do want you to watch out for. So here on number 10, that's the problem we're going to go through together, they're telling us that point B is described by the coordinate pair r comma s, where s, that would be the second value, happens to be 46, and r, the radius, happens to be 37. So keeping in mind s stands for arc length. So here we go. Part A wants us to find xy to the nearest whole number. The issue with that is that to find x, we need to take the radius times the cosine of the angle. And for y, we need to take the radius times sine of the angle. The problem being, we don't have the angle. So we actually need to complete part B before we can do part A. So part B has us finding theta by using the formula for arc length. All right. So S equals theta over 360 degrees times the diameter times pi. So our arc length, S, was given to be 46, and that's equal to the unknown theta over 360 times the diameter. Well, we have the radius as 37, so the diameter is double that, 74, times pi. Okay. So for us to work through solving this, one way of approaching it is to evaluate numerically what we can. So there's a 74 pi whole number on top and divided by 36. So if you have a calculator with you, that would be the time to take 74 pi and divide by 360. Well, I can't undo that, so oh, there we go. I guess I can. All right, so it comes out to about 0.645 ... I would definitely recommend rounding to more than just the nearest tenth. That way we have a little bit more to work with. So 0.65 would be sufficient here. So our 46 is equal to theta times and now of course I can't remember what it said, 0.65. All right. So that's a whole number times theta because we did the evaluation, we got this decimal. So the last step then would be to divide by 0.65 on both sides. So 46 divided by 0.65 will give us our angle theta. So 46, and if you happen to have the answer that you just used in your calculator, you can divide by the exact amount, and it gets you about 71.2 degrees. 71.2 degrees. So that is theta, 71.2. That is critical for us to be able to find part A, which is to calculate x and y. So hopefully with that going on, you've got enough to finish up the problems on page 42. Coming up on pages 43 and 44, the topic is making sense of some radian measures. So we're dealing with the fractions going around the circle again and getting the radian angle measures placed. So the instructions for the 2 pages are to label each point on the circle with the measure of the angle of rotation. Angle measures should be in radians. Recall that a full rotation around the circle would be 2 pi radians. So here's an example. The circle has been divided equally into 8 parts. Each part is equal to 2 pi over 8, or pi over 4 radians. Indicate how many parts of pi over 4 radians there are at each position around the circle. Finish the example by writing the angle measures for E, F, G, and H. So point H here could actually be 0 radians or something else. If we rotate all the way around, that would be 2 pi. So then each of the segments or each of the slices is representing pi over 4. So as we count and go around, point B would be at 2 pi over 4, which reduces to pi over 2. Point C is 3 pi over 4. Point D is 4 pi over 4, which reduces to just 1 pi. So if we keep going and we're counting these values, this is 5 pi over 4 at point E. At point F, it would be 6 pi over 4, which does reduce So be sure to put it in its simplest form. That would be 3 pi over 2. And at point G, that would be 7 pi over 4. By the time you get back to H and you get 8 pi over 4, that of course is 2 pi. So your job then is to continue and finish off page 44 by filling in each of these new circles with their radian angle measures based on the fractions of the circle. On number 12, I would assume that each one of these is in fact equivalent. Ooh, that's a great question. It doesn't really look like it, does it? Well, work together, ask each other, determine what you think is going on there in number 12, and good luck out there.